Hey everyone, this is Unit 1 Lesson 5. EQ is how can we apply the properties of integer exponents to generate equivalent numerical expressions. Learning target, I can simplify a given exponential expression by applying the zero power rule of exponents. Our verbs for today are the same as they always have been. Simplify, we're going to simplify expressions, and we're going to be applying a new rule today. And specifically, we're going to be talking about the zero power rule of exponents. All right, with the brain starter, the first one here, we see that two bases are multiplying with the same base. We're gonna keep the base and add the exponents. The name of the rule would be the product rule. So this is gonna be the product rule. This would be x to the m plus n power. Number two, we see division. This should be the quotient rule. And this would be x raised to the m minus n power. And this right here is the power rule, which means that x raised to the m times n power. All right, let's talk about the zero power rule, which means that if there's 0 as our exponent, what are we going to do about it? All right, in this mini lesson, let's make sure we copy down this entire table. I want everyone to make sure they have this copied down. So if you need to pause the video, please do so. But the main thing that I want everyone to now look at is as the exponents decrease by 1, going from left to right with our base of 5, what do we notice about 625 going to 125, 125 going to 25, 25 going to 5, what do we notice? What operation is happening from left to right? And if we notice, that means that we have to divide by 5. Every single time an exponent decreases by 1, we're really dividing by 5. So that means if we continue this pattern, and we have 5 as this number here, and we divide by 5, 5 divided by 5 is going to give us 1. And if we notice down here, each exponent for the number of 4 is decreasing by 1. And we notice a pattern going from left to right. This one is dividing by 4. Not dividing by 5 this time because our base is 4. If we do 4 divided by 4, we get 1 here. And from left to right again, except our base is 3 this time. Our exponents are going down by 1, so that means we're dividing by 3 every single time we go to the right. And if we do 3 divided by 3, it equals 1. Right, so the patterns that we see from left to right with the powers of 5 is we divide by 5. The patterns that we see in the powers of 4 going from left to right, we divide by 4, and then so on and so forth with the number 3. So if we take a look at all of our answers, all 3 of these answers that are raised to the 0 power, we notice when a power is raised to the 0 power, the power is always equal to 1. All right, so that means that if we have 8 raised to the 0 power, it's going to equal 1. If we have 1,562 raised to the 0 power, it's going to equal 1. If we have a raised to the 0 power, it's going to equal 1. If we have k raised to the 0 power, it's going to equal 1, and so on and so forth. So this is the 0 power rule of exponents. For work time, let's make sure we copy down questions 1, 2, 3, 4, 5, 6. And if you want, you can also try 7, 8, 9, and 10 as extension problems. And our closing/summary is always going to be the same. What resonated with you in today's lesson, and what questions do you still have? If you have any questions, feel free to reach out and just ask.